Hello students, we have completed motion in a plane theory part and all those things, right? So you'll have to be clear with the projectile motion that we have seen and the vector stuff that we have seen, okay? And then we did see like uniform circular motion and some formula that are related to uniform circular motion, right? So you should be clear with all those theory part that we have discussed already, okay? So now we are going to do the PYQ. So we need around like 3 sessions to complete PYQs. Fine. In the first session, which means in this session, we will be doing like 13 or 12 PYQs. Fine. So we got around like 36, 37 questions. Fine. So like around 3 sessions, we will be able to complete all the PYQs of this particular chapter, right? So let's jump into it. Let's see the first question. So the first question over here is 6 vectors vector A through vector F. Okay, so which means they have given you the 6 vectors, fine. So they have given you the directions and all those things, fine. So the diagram is given underneath. Have the magnitudes and direction indicated in the figure, fine. So they have given us the diagram here. Which of the following statement is true? So what I need to find here is what is the statement that is true in the given options. That's what we are supposed to find, right? So here you have got like 6 vectors, and then I'll have to do the vector addition related to the options that they have given over here. So first vector addition is going to be like vector B plus vector C, right? So if I do the vector addition of these two things, then it should look like vector F. If it is right, then option 1 will be my answer, right? So what they're asking us to find is like which of the statement is true. Therefore, if this thing verifies, then that's going to be my answer, fine. So let's do the verification stuff. You should be clear with vector addition. So this is something that we have seen in the first theory part, right? First session of the theory part, where we did like place the tail of one vector on the head of the other vector, right? And then join it from the initial vector, you'll end up getting the resultant vector, right? So that is how we will find the vector addition. So same thing we are going to do here, right? It will be easy, right? Let's do it. So they have given, or the first option is like vector B plus vector C, right? So vector B will be something like this, and then I'll have to put the second vector on the head of the first vector, right? So I could do it other way around also. Both those things will give me the same result anyway. So here first I have chosen like vector B, and then you got like vector C, which will be towards the right. Okay, I have put it on the head of the other vector, so this will be my vector C, right? So the vector F, so the resultant vector will be like something like this, right? So this will be my resultant vector. So is this actually vector F? No, the vector F is actually opposite to that of this vector that we have found over here. Therefore, this is not my answer, fine. So option 1 is not my answer, right? That is something that I have found. Next, we could do like option 2. In the option 2, you got vector D plus vector C, right? So let's do that one. See, you have got like vector D plus vector C, right? So vector D is upwards and then vector C is obviously towards the right. Let us do the vector addition. So if I do the vector addition, you will have, this is like vector C, right? So this will be my F. So is this similar to that of the vector F over here? No, these two things are not similar. They are like oppositely oriented. Therefore, option 2 is also not my answer, fine. So now let's try with option 3. So D plus E gives me F, okay? So vector D is upwards, okay? And then E is towards the left, okay? Let me put it this way. Vector D is towards up and then E is towards the left. So this will be like D and then E. Let me join it from the initial point. So we will have this to be my F, okay? So the initial point should be the starting of the first vector. So this is my F, right? So in this situation, it seems to be pretty clear. F is matching with the diagram that they have given in the question, okay? The vector that they have given in the question. Therefore, option 3 should be my answer, right? So the answer here is like option 3, right? So this is like a simple sum. You should be clear with this one. Just we are using the basic understanding of vector to solve this sum, right? You shouldn't have any confusion in this sum. Let's move on to the next one. Next sum is if the magnitude of sum of two vectors is equal to the magnitude of difference of the two vectors, okay? So what they have given over here is you'll have to add two vectors vectorially and then you'll have to take magnitude of it, right? Which should be equal to the magnitude of difference, which means in the second case you'll have to subtract it, right? So those two magnitudes should be equal to each other, fine. The angle between these vectors is, if those two are equal to each other, then what should be the angle between the vector A and then the vector B, which means those two vectors, fine. So first I will develop an equation for the statement over here. So we will have something like this, modulus of vector A plus vector B, okay? So that will give me the magnitude of vector addition of two vectors, okay, which should be equal to modulus of vector A minus vector B. Okay, so this is how the first equation should be. Then, so obviously this will give me the resultant vector, fine. So the magnitude of resultant vector will be equal to root of a square plus b square plus 2ab cosine theta, right? So I'll use that formula straight away and then I'll end up getting the theta out of it, right? So first, before that, instead of vector a minus vector b, what I could actually write is, for the second equation, I'll be able to write something like this, which is like modulus of vector a plus negative b vector, right? So now I'll be able to input this one into the formula straight away and then I'll be able to get the answer theta out of it, right? So the next, in order to get the resultant vector, so the next step that I'm going to do is root of a square plus b square, okay, a square plus b square plus 2ab cosine theta, right? So that will be my first thing. And then for the right hand side, you'll have like same way root of a square. So instead of plus b square, you will have like plus negative b square, right? Minus b the whole square. So next term will be like plus 2ab cosine theta in the first part. In the second part, as you have like negative sign into it, you'll end up getting minus 2ab cosine theta, fine, right? So we will have this extra one negative sign coming because of this negative thing, okay? So we'll do the pictorial understanding for this step, okay? After the completion of this sum, I'll do that pictorial understanding behind it, right? As if now, because of this negative sign, you ended up getting this negative sign, obviously, because like you have this negative sign, right? So in this next part, in the third term, you should obviously have a minus b cosine theta, therefore you got something like negative, right? Okay, so this step should be clear as if now. We will do the pictorial understanding of this one after completing the sum, okay? So now let me solve these two equations. You'll end up getting the answer straight away. So if I square it on both sides, these two roots will get cancelled out. Then you got like a square plus b square. Same way you got like a square minus b the whole square gives me the b square. Therefore those two things will get cancelled out. Then if I just do the rearrangement thing, I'll get the cosine theta, right? So in the next step, you get something like this. You will have 2ab cosine theta, which is equal to negative 2ab cosine theta, right? So if I add those two things, you will have like 4ab cosine theta, which will be equal to 0, right? So 4ab cosine theta will be equal to 0, which means cosine theta will be equal to 0, right? So if cosine theta was equal to 0, then the theta should be equal to 90 degree, right? You should know that theta graph which we have seen in the theory part, right? So cosine theta actually is 90 degree offset from the sine curve, right? Therefore, cosine 0 will come for, like cosine 90 degree will be equal to 0, right? Therefore, theta here should be equal to 90 degree, right? You should be clear with the theory part, right? So the answer here is like 90 degree, fine. So now I have got the answer, which is like option 4, 90 degree, right? Now let's see the logic behind this negative sign that I put over here, right? So in this step I have told you straight away. Now let's draw the vectorial stuff and then let's find it out, okay? So just two more extra steps, you will be able to understand it clearly, fine. So first you have got like, let's take it this way, this could be my vector A. So this is my first vector. Then you have got something like this is like the vector B, fine. So the angle here over here is actually, let's give some value to it. I'll put it like 30 degree, fine. So for easy understanding purpose, I'll give the value straight away. So this is like 30 degree. So this will be my vector A, vector B, right? Then what should be my negative B vector? It should be exactly opposite to that of vector A. Therefore, negative B vector is something like this. Opposite to that of this one. This will be my minus B vector, right? So if I split it, this angle will be equal to 30 degree, right? So these two angles are actually opposite angles, therefore these two should be same, fine. So the angle between vector A and vector B was equal to 30 degree, and the angle between vector A and then minus vector B was equal to 180 plus 30, therefore so that should be somewhere around like 210 degree. So let's put it this way, 180 plus 30 degree. So I'll take it in that fashion itself, and now let us put the resultant vector into it, okay, that formula, fine. So here resultant vector R was equal to modulus of vector A minus vector B, right? So in this step, if I put the resultant vector of that equation straight away, you will have A square, okay, so that will be my first part, and then plus minus of B square, which is going to be like B square, and then plus 2AB. I'll put the cosine theta into it. So the theta here will be like the angle between A and then the minus B vector, which will be like 180 plus theta, or else I'll be able to substitute this one as 180 plus 30 degree in this situation. Okay, fine. So 180 plus 30, then how should it be? It should actually be like cosine 180 plus 30 degree, right? So you will have cosine 180 plus 30 degree, right? So what will be the answer for like 180 plus 30 degree? So let us draw the graph to get the answer for it. So if I draw the graph, cosine graph, you will have, it starts from maximum and then it goes to 0 for 90 degree, then it goes to minus 1 for 180 degree, then after that it again goes to 0 in the negative value. Okay, so if cosine 30 degree was something like root 3 by 2, then what will be like cosine 180 plus 30 degree? It will be like minus root 3 by 2, right? Therefore it is pretty obvious these two values are actually opposite to each other. Okay, so if the value here is like positive, then 180 plus theta or 180 plus 30 degree will be like negative of the same magnitude, right? Therefore cosine 180 plus 30 degree is nothing but the negative cosine theta, right? So if I substitute that one straight away, you will end up getting this thing, right? A square plus b square minus 2ab cosine theta. Fine. So instead of writing it as cosine 180 degree plus 30 degree or theta, I'll be able to write it straight away as minus cosine theta. Therefore you will have root of a square plus b square minus 2ab cosine theta. Okay, so this is the logical understanding for putting this negative sign in front of this term, right? So you should be clear with this one. So anyway, even if you do not know this one, straight away from the math classes that you have learned, you should be clear, right? Vector A minus vector B actually means a square plus b square minus 2ab cosine theta. This thing is something that you could have learned in your math class. Actually, the logic behind it is from the pictorial understanding that we have seen right now. Okay, so you should be clear with this sum. No doubt should be there. Let's move on to the next one. Next sum is if modulus of vector A plus vector B is equal to modulus of A plus modulus of B. Okay, so here it is, the entire term is into the single modulus. Here I have taken the magnitude separately and then I added it. Okay, then the angle between A and B, then what should be the angle between A and B? That's what I need to find. So this sum is actually similar to that of the previous sum, but the solving steps are something different, but these two are like similar pattern sums. Fine. So now let's do the solving. For the left hand side, I'll put the relation straight away. So we'll have root of a square plus b square plus 2ab cosine theta, right? Then for the right hand side, you got like modulus of vector A. So modulus of vector A is nothing but the magnitude in itself. That's going to be A. Okay. So here I have put the magnitude of A. That's what like A square. And then plus B square plus 2AB cosine theta. Here in this situation, first I have took the modulus, which means first I found the distance magnitude, then I added it, right? Therefore, modulus of vector A is nothing but the A itself. Therefore, you will have A plus B. So you got the relation straight away. Then if the root on the one side of the equation goes to the other side, it gets squared. Therefore, you'll have a plus b the whole square, which gives me a square plus b square, and then you'll have like plus 2ab, right? So you'll get that one straight away. So if I do the solving, I'll get the answer. Fine. So the next step is like a square plus b square plus 2ab cosine theta, which is nothing but a square, a plus b the whole square. So I'll have like a square plus b square plus 2ab, right? So this is the normal square stuff. Okay, so if I do the cancelling stuff, a square a square a square b square a square b square will get cancelled out. Then you'll have like 2ab on the left side and the right side. So those two things will get cancelled out, right? So you'll just be left with cosine theta, which is equal to 1. Okay, so if cosine theta was equal to 1, then what should be the theta? Theta should actually be equal to 0 degree, right? So it starts from the maximum. Therefore, theta will be equal to 0 degree. The answer here is option 3, right? So you should be clear with this sum, right? So these are like simple sums. You shouldn't have any doubt. Let's move to the next one. Next sum is based on differentiation. Let's see what the sum is. The x and y coordinates of the particle at any time are x equals 5t minus 2t cube. They have given us the x coordinate and y which is equal to 10t, right? So respectively. So they have given us x and then the y relation where x and y are in meters and t is in seconds. Fine. So they are in SI units. The acceleration of the particle at t equals 2 seconds. What I'm supposed to find is the acceleration of the particle, right? So they have given us the position equation xn with respect to x and y coordinates, right? So in motion in a straight line, we might have solved this pattern sum, right? So there it will be like only one dimension, which means they will give you only x. So here, as this is like motion in a plane, they have given us like two equation. One is related to x and the other one is related to y. So these are like simple, fine. So with respect to x, I put like I cap, and then if it was respect to y axis, then I'll put like j cap. That's it, right? Then rest all other solvings are just the same thing, fine. So if I differentiate it once, the position, I'll end up getting the velocity, and then if I differentiate it twice, I'll end up getting the acceleration, fine. These are like super easy sums. Straight away I'll get the answer, fine. So the first one is like velocity along the x, right? To get the velocity along the x, I'll differentiate the x equation one time and then I'll put like I cap to it. So if you differentiate the x equation, you'll have like in 5t, you'll end up getting 5, and then for minus 2t square, you'll have like minus 4t, right? So the first equation is, so the first I equation will be something like this. 5t minus, 5 minus 4t, okay? This will be like I cap, right? So in motion in a straight line, this will be the only part that we would have studied. Here, as you have like two-dimensional motion, I need like two vectors to represent it, okay? So one is for like I cap, which is for x direction, and then for j cap, for y direction, I'll put j cap, right? So plus, I'll have to differentiate this y equation. If I differentiate it one more time, you'll have like 10, right? So t will go away, therefore you'll have like 10 j cap. So this will be my velocity equation. If they asked us to find the time velocity at t equals 2 seconds, I'll have to use this equation straight away. In this situation, I'll have to find the acceleration, right? Therefore, I'll differentiate it one more time to get the acceleration. So if I differentiate it one more time, vector A will be equal to 5 goes to 0 as it is a constant. Then you'll have like minus 40. If I differentiate that one, you'll have like minus 4 I cap, right? And then plus 0, right? So you will not have any j component into it in this situation. If you had j component, then obviously you'll have to consider it. In this situation, it goes to 0. Therefore, the answer here is vector A will be equal to minus 4 I cap. So that was the acceleration, right? So if minus 4 I cap was the acceleration, then what they're asking us to find is the acceleration of the particle at t equals t seconds, 2 seconds, right? So here you do not have any time to substitute it over here. Therefore, this is actually a constant acceleration motion with an acceleration of negative 4 meter per second square, right? So in this situation, it just matches up directly. They haven't mentioned anything related to magnitude of things of that sort, okay? If they've given us the magnitude, only option that I could mark is like 4 meter per second square. But in this situation, you just got like one component. That too they have given with the negative sign itself. Therefore, that should be my answer, fine. So the answer here is option 2, right? You should be clear with the sum. No doubt should be there. Let's move to the next one. Next sum is statement based sum. Let's see what the sum is. The position vectors of a particle vector r as a function of time is given by vector r equals, they have given us the equation, okay? So when you look at the equation, it is pretty clear. 4 sine 2 pi t I cap, and then you got like 4 cosine 2 pi t j cap, right? So this is one of the equation that you have seen in the theory part, okay? So this is actually the equation of the circle, right? So 4 and 4, both those things are same. So that should be my radius, and then you got like sine component, and then you have like cosine component into it. So I has sine in here in the situation, and then j has cosine in the situation, okay? So then this should actually be the clockwise rotation, fine. So these are something that we have discussed in the theory part itself. So it should be clear this is actually an equation of the circular thing, okay? And then instead of theta, they have given us like 2 pi t, right? So if they give you in this pattern, it actually means theta equals omega t, okay? Angular velocity times the time, that gives me theta. That's what they've given over here, fine. So you'll get used to these kind of notation, fine. So it might be new when you look at this, but this thing will come again and again in the upcoming chapters and questions, so I'll get used to it, right? Then what they've given is where capital R is in meters, T is in seconds, and I and J cap denote unit vectors along the x, y directions respectively, fine. So they have given the description of all of this vector components over this equation, okay? What I need to find is which one of the following statement is wrong. So this is important. So I'll have to get the wrong statement in it. Which one of the statement is wrong for the motion of the particle, okay? So first let us do it. Magnitude of the velocity of a particle is 8 pi meter per second. So to get the velocity, what I need to do, I'll have to differentiate this equation and then I'll have to get the magnitude to it. Okay, so if I do that one, I'll get the magnitude of velocity of this equation. Fine. So let's leave the first option and let's see the rest three options. Okay, in this case, option 2 is like path of the particle is a circle of radius 4 meter. Obviously this is right. Fine. So because you have the coefficient to be like 4, therefore obviously the path of the circle should be having a radius of 4 meter. Therefore option 2 is actually correct, which is not the answer, right? So 2 is correct, which is not the answer. Then let's verify the third one. Acceleration vector is along minus r cap, r vector. So that is obviously right. Fine. So generally when an object is moving in a circular path, obviously the acceleration should be directed towards the center origin. Okay, so if the acceleration is directed towards the origin, vector r will be like away from the origin, minus vector r will be like towards the origin. Therefore acceleration vector along minus r cap is r vector is actually right. Therefore that shouldn't be my answer. So option 3 is also not my answer. Then you have got magnitude of acceleration vector is v square divided by r, where v is the velocity of the particle, right? So we have seen this derivation. Obviously magnitude of centripetal acceleration will be like v square divided by r. That too is not my answer. Therefore you have got option 4 also is wrong, also is right. Therefore that shouldn't be my answer. So that thing is also done. Fine. So only option that is very left to verify is like option 1. Most likely that should be my answer. Let's verify it. Fine. While considering these two options, option 3 and option 4, you should be clear this motion is actually an uniform circular motion because 2 pi was the angular velocity. Okay, so 2 pi, so obviously this is like omega times t, therefore angular velocity omega was equal to 2 pi, which is like constant. Fine. So if the angular velocity is constant, then obviously it doesn't have any angular acceleration into it. Therefore this motion is uniform circular motion. Therefore acceleration will be directed inwards. You shouldn't have any tangential acceleration into it, right? So that is why option 3 and option 4 is also correct. Therefore what I need to find here is the wrong statement there. So option 3 and option 4 wouldn't be my answer, right? So now let's verify the option 1. While comparing the option 1, first I'll have to differentiate the above equation, right? So to get the vector v, I'll have to differentiate the first part. So if I differentiate the first part, 4 sine 2 pi t, right? So if I differentiate sine, I'll get like cosine, right? So I'll have 4, instead of sine I'll put like cosine 2 pi by t. Fine. So you got like entire term into it. You should be clear with differentiation, right? So I'll differentiate this one once and then I'll multiply it to the coefficient. Okay, so if I differentiate like 2 pi into t, you will have tt, that will be like 1. Therefore you'll have like 2 pi. So you'll have that constant which I need to multiply to the coefficient. Therefore you will have 4 pi multiplied to the 2 pi multiplied to the coefficient, that you will end up getting 8 pi. Fine. So in this situation I'll write it straight away. So you'll have like 2 pi into 4 cosine 2 pi t, right? You should be clear with this differentiation and then you got like I cap to it. Fine. So the first step is done. So next we will do the differentiation of the second part, which is like j cap, right? So if I do the differentiation of that one, so again you'll have like same thing repeating once again. So I'll have like 2 pi into 4. Instead of cosine, I'll have like negative sign, right? If I differentiate cosine, I'll end up getting negative sign. Therefore we'll have like negative sine 2 pi t j cap, right? So now I have got vector v in this situation, right? So to get the magnitude of this velocity vector, I'll have to take the resultant vector, right? So to get the resultant vector, you'll have like root of a square plus b square, and then you'll have like plus 2ab cosine theta. So that's what we will generally use, but in this situation theta will be equal to 90 degree, right? Because this one component is like I and the other component is like j. Therefore that 2ab cosine theta is not needed because theta was equal to 90 degree, right? So I'll just do it straight away. So I'll have root of a square plus b square will give me the answer straight away. So that will be like root of, so for a square I'll put like 8 pi cosine 2 pi t the whole square, or you'll have like 8 pi square and then you'll have cosine square 2 pi t. Okay, cosine square 2 pi t. So this will be my first term, and then the second term will be like same. You will have 8 pi the whole square and then you will have sine square 2 pi t, 2 pi t, right? So now let's factor out 8 pi square from it. You will have, if I do that factor out stuff, you'll have 8 pi square, and then inside the bracket you'll have like cosine square 2 pi t plus sine square 2 pi t, right? So obviously that should be equal to 1. Okay, cosine square theta plus sine square theta is equal to 1. That's a basic trigonometric relation that you need to know. So that will be equal to 1. Therefore the answer here will be like, if I do, so it should be like 8 pi the whole square, right? So if I just take the square root of it, you'll have the answer to be like 8 pi. So the velocity will be equal to 8 pi. The magnitude of velocity was equal to 8 pi. So that's what they have given over there in the option also, which is like 8 pi meter per second, right? So obviously option 1 is also not my answer, right? So in this step, you should be clear with this differentiation that we have done over here. Whenever you have like sine theta, if you do the differentiation of it, you'll end up getting cosine theta, okay? But the thing is, they have given extra component inside the theta, okay, which means something like 2 theta, 2 pi theta, fine. So when you do that kind of differentiation, then you'll have to consider this entire term to be like single term, which will give me cosine 2 theta, and then I'll have to differentiate that 2 theta one more time and multiply it to the answer, okay. So that's a kind of chain rule, okay. You should be clear with this, that stuff. We might have seen that one in the previous chapter also, so you should be clear with this part, fine. So if I do the differentiation of the term that is inside it, then you'll have like 2, one more 2 pi just popping out of the 2 pi theta, okay. So you'll have like 2 pi cosine 2 pi theta, fine. So you should be clear with this particular step, okay. So the answer here was like 8 pi. So the thing is, all the 4 options is actually correct. So the answer here is none of the option is correct, okay. So if when you get such a kind of question, you shouldn't mark any options, right? So if you end up marking one of the option, then they'll give you like -1, because none of the option was right. You ended up marking one of the answer, therefore they'll give you -1. So when you encounter such a type of question, this type of question rarely comes in the NEET examination, okay. Sometime you will have some question error into it. So in those situation, so if none of the option was correct, then you will have to leave that question. If you leave that question without marking any option, they'll just give you 4 mark, okay. If you end up marking any one of the options, then they'll give you like -1, fine. So whenever you get such a kind of question, so it seems that none of the option was right, then in that case, just leave the question and move to the next question, okay. So unanswered question will be given mark, fine. So these kind of question rarely comes, okay. That too in physics, you'll end up getting these kind of sums, okay. Rarely you get in biology, you get like 2 options to be right. So in that situation, you just have to mark either one option, okay. If you end up marking correct one option, if you know that 2 option was right, but the thing is, you just mark one option which is the right one, then they'll give you like 4 mark, okay. Let me tell you the other way. Let's make it this way. 1 and 2 is correct, and then 3 and 4 was wrong, right? If you get it such a fashion, then you just mark either option 1 or option 2, right? In that situation, they'll give you 4 marks. Or else if you end up marking like 3 or 4, they'll give you like -1. So that's how we'll have to approach this NEET examination, fine. So in this situation, as none of the option was right, therefore you shouldn't mark any of the option in the question, okay. So you should be clear with this sum, right? So you should be clear with the statement based sum that we have solved over here. There shouldn't be any doubt. Let's move on to the next one. Next sum is, a particle is moving such that its position coordinates x, y are 2 meters, 3 meters at time t equals 0, and then you have 6 meters, 7 meter at time t equals 2 seconds, and 13, 14 meters at time t equals 5 seconds. What they are asking us to find is average velocity vector from t equals 2 to t equals 5 seconds. So what I need to find here is the average velocity vector, fine. So to get the average velocity, generally what will I do? I will get the entire distance covered or displacement covered divided by the time, gives me the average velocity, right? Same thing that I'm going to do here, right? So these kind of sum I have seen already in the motion in a straight line. There you just got one dimensional motion, therefore I didn't include I cap and j cap. But here I'll have to include I and j because this is actually two-dimensional motion, right? So the initial position was like 2 meters and 3 meters, which means like 2 I cap plus 3 j cap. And the final position was like 13 I cap and 14 j cap, right? So final minus initial gives me the displacement divided by the time, which will be like 5 seconds, okay? That will obviously give me the average velocity vector. So to get the average velocity vector, you will have like final position minus initial position. Final position was like 13 I cap plus 14 j cap negative of 2 I cap plus 3 j cap, right? Divided by the time, which will be like 5. Fine. So just do the solving, you'll get the answer. Fine. So 13 minus 2 gives me 11 I cap. 14 minus 3 gives me same 11 j cap divided by 5. So the answer here is 11 by 5 I plus j cap, which is like option 4. Right? These are like easy sums, right? You shouldn't have doubt. Let's move on to the next one. This sum is also similar to that of the previous sum that we have seen. Let's see the sum. A body is moving with a velocity 30 meter per second towards east. Okay. So east actually means towards the right in the situation. After 10 seconds, its velocity becomes 40 meter per second towards the north. Okay. So initial velocity was something like this. Vector Vi was equal to 30 I cap, right? Towards the east means it is towards the right, therefore it should be like I cap. So that was my first thing. And then you got like after 10 seconds, its velocity becomes 40 meter per second towards the north. Therefore, final velocity was 40 j cap, which means towards the north. Fine. The average acceleration of the body is what I need to find is the average acceleration. Fine. So acceleration means final velocity minus initial velocity divided by the time. In the situation, the subtraction should be done vectorially. That's it. Finished. So easy sum. You'll get the answer straight away. So A vector A was equal to final minus initial. Therefore, you'll have like 40 j cap minus 30 I cap divided by the time interval that was equal to 10. Okay. If you just factor out 10 from I cap and then j cap, those zeros will get cancelled out, right? I'm doing it straight away. So to get the magnitude of this acceleration, that is going to be my answer. Therefore, A will be equal to root of 4 square plus 3 square. Obviously, this will be equal to root 25, which is nothing but 5. The answer here is 5 meter per second square, which is like option 4, right? You should be clear with this sum. Let's move on to the next one. Next sum is a particle moves in xy plane according to rule x equals a sin omega t and y equals a cosine omega t. Okay, so they have given us x equals a sin omega t and then y to be like a cosine omega t. So it is pretty clear this motion should actually be a circular motion, right? So instead of giving it as I cap and then j cap, what they have done is they have just given the x term separately and the y term separately, right? So if I get a vector r for it, then obviously it will be like a sin omega t I cap plus a cosine omega t j cap. That too, those coefficients a is like same, right? So in both those x and y, the coefficient a was like same. Therefore, this should be a circle, right? The particle follows. So what path it should follow? That's what they're asking us to find. The option one is like elliptical, circular, and then the parabolic path, or it should be a straight line. So we already know the answer is like circular path. Therefore, the answer is option 2, right? So these are like simple sums, right? So we have seen the intuition for this sum already in the theory part. If you're strong in the theory, you should obviously be able to understand this one easily, right? Let's move on to the next one. Next sum is graphical based sum. Let's see what the sum is. A particle starting from origin 0, 0 moves in a straight line in the xy plane. Okay, so it starts from 0, 0 and it is moving in a straight line. Okay, its coordinates at a later time are root 3 and 3. Okay, so they have given us the final position. The path of the particle makes with x-axis and angle of. So what I need to find here is the angle. Fine. So let me put the initial point and then the final point. I'll just draw a line. As it is moving in a straight line, you just draw a straight line. Fine. So you will end up getting the path. Then you'll have to compare it with the x-axis. So if I compare it with the x-axis, I'll be able to get the theta, right? So this is simple graph based sum. Okay. So let me draw a graph thing. So you got like this to be my x and this will be like my y. So the object starts from 0, 0. So that was my starting point and then it ended up at root 3 and then 3. X was equal to root 3. And the final position was like this one, which is like root 3 along the x and then 3 along the y, right? So to get the path, just connect these two lines. I'll end up getting the path. Fine. So here obviously this x will be equal to root 3 and the y will be equal to 3, right? So to get the theta, what could I actually do? I'll be able to take tangent theta, right? So tangent theta actually gets me opposite divided by adjacent. So these two are the sides that I know. Therefore, tangent theta will be equal to opposite divided by adjacent, which will be equal to root 3 divided by root 3, right? So 3 divided by root 3, that will be equal to root 3, fine. So what theta will give me root 3 for like tangent component, it should be like 60 degree, right? So theta should be equal to 60 degree in the situation, right? Therefore, the answer here is option 2. Fine. You should be clear with this sum. Let's move on to the next one. Next sum is also vector based sum. Let's see what the sum is. A particle has initial velocity 2 I cap plus 3 j cap, right? So they have given us the initial velocity and acceleration 0.3 I cap plus zero point 0.2 j cap, right? So acceleration is also given. What I need to find is the magnitude of velocity after 10 seconds will be. So I'm supposed to find the final velocity, right? So it is pretty clear. It is a constant acceleration motion. Therefore, I'll be able to use the kinematic equation, right? So there are like three kinematic equation, obviously. In this situation, the relation is between time and then the velocity. Therefore, I'll use the first kinematic equation, which is like v equals u plus at. So this is the equation that I'm about to use here. What I know is initial velocity v is known, u is known, and then acceleration is also known, time is also known. Okay, what I need to find is the final velocity, right? So I'll just input all those parameters straight away into it. You'll end up getting the answer. So v will be equal to, instead of initial velocity, I'll substitute 2 I cap plus 3 j cap, right? And then you have like acceleration, which is nothing but 0.3 I cap, and you got like plus 0.2 j cap multiplied by the time, which is like 10 in this situation. So if I do the inner multiplication, I'll have 2 I cap plus 3 I cap. Therefore, that will give me like 5 I cap. And then for j cap, you got like 3 j cap plus 2 j cap, which will give me like 5 j cap, right? Now I have got the vector velocity, right? What I need to find is the magnitude of this vector, right? So that's what they're asking us to find in the option. Therefore, the magnitude of this one will be like modulus of vector v, which is nothing but root of a square plus b square. That will give me 5 square plus 5 square, right? So in this situation, if I factor out 5 square, you will have 2. I mean 1 plus 1, that will give me like 2, right? Obviously, if I factor out 5 square, you'll have like 1 plus 1, which will be like 2, right? So if I take root for it, you will have like root 2 5. So the magnitude will be equal to 5 root 2, right? 5 root 2 will be my answer. Okay, so the answer is option 2. Fine, so these are like simple sums, right? Just use the first kinematic equation. Only thing is, here I'll have to consider both those components and I'll first solve it vectorially. Once I end up getting the final velocity in terms of I and then j, then I find the magnitude of it, which is nothing but the Pythagoras theorem, right? Root of a square plus b square will give me the answer, right? No doubt should be there in this question. Let's move to the next one, which is the final question for this session, right? Next question is also same as that of the previous question that we have seen. Only thing is that they've changed the numericals over here, okay? Let's solve it. A particle has initial velocity, which is like 3 I cap plus 4 j cap, and has acceleration of 0.4 I cap plus 0.3 j cap. Its speed after 10 seconds is fine. So here same way I'll have to find the final velocity, right? So I'll use the same kinematic equation, which is like v equals u plus at. So if I do the solving, instead of u, I'll substitute like 3 I cap plus 4 j cap, right? Then for acceleration, you got like 0.4 I cap. Obviously, I'll multiply it with 10. Therefore, you'll have like 4 I cap 80. So I'm doing it straight away. And then for j component, you'll have like 0.3 into 10, which will give me like plus 3 j cap, right? Now I have got the final relation, which will be like 3 I cap plus 4 I cap, that gives me like 7 I cap, and then 4 plus 3 also gives me like 7 j cap. Now we have got the vector v, right? What they're asking is to find the modulus, right? So you'll have like modulus of vector v, which will be equal to root of a square plus b square, that gives me 7 square plus 7 square, right? Same way, you do the same stuff again, factor out 7 square, and then you'll have like 7 root 2. That will be my answer, right? The answer here is option 2. Fine. You should be clear with this sum. The sums that we discussed in this session were mainly related to vectors, okay? These are that vector addition based sums, and then these are sums that are related to kinematic equation using the two-dimensional thing into it, fine. So in the next session we will do sums that are related to relative velocity, and then we will see sums that are somewhat related to projectile motion and those things, fine. So in the next session also obviously we will do around like 12-13 sums, fine. So with this the video gets completed. Bye.